All right, these few notes should look familiar. We took them down in task number 1. If you didn't get them down, you want to make sure you have them now. The one thing we want to add to this is that when we looked at the sine graph, we noticed that it had a 5-point pattern. And so maybe you list this as the sine pattern, because this is how we're going to make graphing really easy. So we're going to see that on the next slide, that the pattern goes 0, max, 0, min, 0. So I'm just pausing, so if you want to pause and get those notes down. All right, so how possibly is that going to look? So it tells us what is the graph of one cycle of a sine curve with the amplitude of 2. So let's start writing some information down. A is 2. We know our period is 4 pi, and it's not reflected. That's what that says. It's not negative. And so then we want to write the equation. But first, let's focus on graphing. So how do we show period and how do we show amplitude on a graph? So what we're going to do is on the y-axis, that's how you're going to show your amplitude. So here's your 0. This is going to be 2 and this is negative 2. Obviously, these tick marks in between are 1 and negative 1. And then you're going to draw out what they want for the period. So it doesn't really matter how long that line is, but this 4 pi, whatever it tells you your period is, goes out here. And then we need to divide our graph into fourths, and so that's how we scale it. So half of 4 pi, right here in the middle, is 2 pi. Half of just 2 pi over here is pi, and the halfway distance between 2 pi and 4 pi is 3 pi. All right? And then we had our pattern where we said it goes 0, max, 0. I'm just using z's for 0, min, 0. So here's how you do it. If you guys have your notes still in your notebook from what the parent function looked like, it follows the same pattern even though our x-axis might be different. So at each of these sections, we're going to make one of those patterns. So at 0, we're at 0. Next section, we're going to go up to max. So we're at 2. Next section, we're going to go down to 0. Next section happens to be 3 pi this time. We're going to come down here to negative 2. And then our final section, we come back up to 0. See, we followed our pattern. And now we want to fill in a smooth curve that looks like a sine curve. All right. That's it. That's how you graph. So take a moment, and if you need to pause after this slide and get all your information down. Now it says they want us to write an equation. Well, we were given P, not B. But remember, we have an equation that has B in it. So there's our B right there. What do we know? We know period. So we know this. So we have 4 pi equals 2 pi over B. Well, now to get B out of the denominator, I multiply both sides by B. So I end up with 4 pi B equals just 2 pi. And then I divide both sides by 4 pi. So I can see B is going to end up being just 1/2. So here it says I complete half of one cycle in 2 pi. And let's see if that's true. If I come over here between 0 and 2 pi, I have only completed 1/2 of the cycle. We already know what A is, and so then we fill in our equation is 2 sine 1/2 theta. All right. let's give you a chance to try this. So it gives you similar information you had before. You have an amplitude of 0.2. Your period is 8 pi. So remember, that's how you're going to divide your graph into 4 sections, and it's not reflected. So go ahead and pause this slide, and then when we come back, we'll do it together. All right, start talking again so you can't hear my child yelling at his video game and his friends. So here we know we have A equals 0.2. We know our period is 8 pi. And so that's enough to get started graphing because we also know the pattern. So this time, here's 0 in the middle, here's negative 0.2, and this is positive 0.2. I just come out for any amount of length, so let's call this 8 pi. I divide it into fourths, so half of that is 4 pi. This is 2 pi, so this has to be 6 pi. And it's not exact. I'm not using graph paper. You probably should. And then we're going to follow our pattern. 0, max, 0, min, 0. And then draw our smooth sine looking curve in, I don't have a complete smooth surface here, but something like that. All right. Now, this is just a little bit different. This gets us also to the point where we can write an equation from a graph, which we've practiced in task number 1, is now they're giving us the equation. So what do we know from here? Well, we still know A, so we know how to set up our y-axis. But we don't know what our period is. We know B. B is 2. So in that case, we can find the period. So period is 2 pi over B. So we're going to have 2 pi all over 2. So my period is pi, and that's how I'm going to set up my graph. And so I don't have to start the 7 minutes over. We forgot to write our equation. So we know our equation is going to start out 0.2 sine. We didn't have B yet, but we can solve for it. So 8 pi equals 2 pi over B. If I multiply B by both sides, I get 8 pi B equals 2 pi. And then divide both sides by 8 pi. I get B equals 1/4. So my equation is 1/4 theta. All right, sorry about that. All right, now we're going to work on finding or graphing. So we did all the hard work already on this. We're just going to do our same process except for this. We can list it as positive 1/2, or you can put it as 0.5 and negative 0.5. And here is your 0. Draw out a certain distance for this. Now this time though, our period is pi. We're going to split that in half. So half of pi is pi over 2. Half of pi over 2 is pi over 4. And this is the one that's a little trickier, but if you just add pi over 4 to pi over 2, then it's going to be 3 pi over 4. And then we fill in our pattern. 0, max, 0, min, 0. Right. There's our graph. And that's it. I do expect you guys to have some questions on this, so just remember office hours Tuesdays and Thursdays, or anytime you need it, I can fit you in any day of the week.